get to.
Yeah.
We're about an hour and a half into a call, and one of us says, "I wish we had recorded this."
Yes, that's right.
Right. But anyway, you want me to go first? Yeah. Okay. Okay. So, where do I start? I'm someone who.
I don't see the, oh yeah, it is recording. Sorry, go ahead.
Okay. Yeah. 40 years or so ago, I was basically disabled for about 2.5 years. Environmental illness is what it used to be called, until the allergists got a hold of it and just decimated Theron Randolph and Claudia Miller and some others, because Theron Randolph dared to call it an alternative approach to allergies. And in a sense it is, but they'll only now see maybe there's a mechanism that could be used. Anyway, the point is that that's how I got into what I'm doing. It took me another 10 years after that 2.5 years before I could really work full time. And I gradually was able to do that by visiting patients from the doctor, one of many doctors that I went to that was able to help. And I found my calling, I guess, if you could say, of helping people understand the indoor environment in an individual way rather than a public health or statistically large group way. And I was able to somewhat intuitively, I guess, or experientially, I like that word better, figure out what was going on. And in 1999, I wrote a book called Starting Points for a Healthy Habitat. It's been out of print for a number of years now. But that led to a current president in the year 2000, president of the Indoor Air Quality Association, finding it. She and her husband were interested in it. They were indoor air and quality engineers in Florida. And she invited me to speak to the conference. I did. Someone there heard me and asked me to serve on a committee that was just forming that by the year 2003, we had written the first mold remediation standard in the US. And it's a couple of years later, it became ANSI accredited, and it's still the primary one. That led to work on water damage standard, air duct cleaning, ANSI accreditation. I taught a couple of organizations about the fundamentals of it. What I'm leading up to, Gary, is that even though I started out with a very direct personal experience, it expanded to others, and then it expanded into professionalism. And so I've then served on the board of Indoor Air Quality Association for about 13 years. I was president for 2.5. After that, I was asked to serve as vice president of practice for the International Society of Indoor Air Quality and Climate. I've served on medical committee that wrote medical practice parameters. And with ASHRAE, I don't know if you're familiar with that organization or not. Several committees, several policy statements there, and I'm vice chair of 2 committees. I said I would never ever join ASHRAE, but I did. And this kind of leads then into my interest in John and relational theory, system science, Rosen, and the main topic today is that one of the documents that we wrote that just came out a year ago at ASHRAE was Building Dampness and Health. And it was the first document along that line about building science anyway, that took a look specifically at people, not just the building, but of people. And we had a meta analysis by Mark Mendel on the epidemiology of this, and he found some really great studies to connect it. So maybe the best way to say what I'm doing And my interest here, and what I talked to John about is, and I realize I'm going beyond who I am, but I know John, and I have a general idea of you, Gary. Is I did a presentation to ASHRAE where they wanted me to talk about the need for health and looking at healthy buildings, because they now have a 5-year strategic plan to include health in buildings, not just reported satisfaction, but of health. And the way I presented it was basically buildings are closed systems. We've got the laws of chemistry and physics. The ASHRAE handbooks are full of formulas that nobody can understand or read or use anymore, but they got formulas for all that. But the people are not closed systems of physics and chemistry, they're biological, they're open systems. So how do you integrate those? And my suggestion was that you don't integrate them. What you do is you further isolate them, make the buildings really clear, make the people separate and clear, and then look at the relationships, if any, between them. And we know buildings affect people, and we know people affect buildings. So there's fertile ground in there to work. So that's who I am, and where I am in all this. And John suggested that you come in to help us, because I think he said you're looking at ways to communicate with engineers, if I heard that right. So I'll quit talking and let you talk, Gary.
Okay, thanks. Yeah, I guess, yeah. That's really interesting. So there are a few things that popped up in my mind as you were talking about connections, but I'll go through my background quickly. So originally I was a chemist, an industrial chemist. Then I was essentially, I'd say I was more a technician, and I did a lot of my education part-time, with the support of my company, and eventually I did a degree in applied chemistry. But then when I went back to my company, I joined their graduate development program, and ended doing up stuff that wasn't chemistry. I did some work on relational database systems, bringing together the management control systems of 2 companies, because the company was merging with another company. And after doing that for a while, I then went into sort of like more, let's say, more formal software engineering in digital communications and intelligent networks. And then after that, while I was doing that, I moved from actually doing the software engineering to managing the software engineering, and I managed 2 major product releases to big British telecoms and also other customers. And then after that, I then moved into international project management, where I was doing essentially contractual delivery of telecommunications infrastructures. And then from that, I moved into corporate project management. So managing project, so sort of like developing and coordinating the project management development of the corporation itself. So looking at things like life cycle management, for instance, and looking at the phases of the life cycle, and establishing standards for life cycle management for product development, organizational transformation, and also contractual delivery. And then in the telecommunications crash, I then moved. I was recruited by my current company, who wanted me to develop technical management as a discipline within the company. Parallel to that, I'd also been doing some. I was looking at the potential of going back to chemistry, and I ended up doing a course called Molecules in Medicine with the Open University, and I was kind of doing that just for fun, but I was also looking at the potential of moving back into a chemical environment. But while I was doing that course, towards the end of the course, we were asked to do, and the course is all about looking at the molecules in medicine. It was looking at neurodegenerative disorders, cancer, inflammation, infections, and all of these different types of disease, and how the medicine influenced the course of the disease. And towards the end of the course, I had to give a talk on a subject of my own choice. I had to do a poster presentation and also a mini review. And I chose to look at the role of transforming growth factor beta in cancer because it had paradoxical properties. And I thought it'd be interesting to try and find out why it was doing what it was doing. And I ended up publishing a paper with the Open University in the BMC Journal of Inflammation. It was cancer, inflammation, and the 81 and 82 receptors. Because basically what I'd done is I'd worked out a new way of thinking about how cancer essentially behaves in the body when it starts to exert stress in its microenvironment. And this is what leads to essentially malignancy. And I'd worked out that by using existing cardiovascular drugs in combination with other drugs, we could potentially regress all solid tumors. So that was kind of my introduction into system science, I would guess, because I mean my current role, I'm the lead architect of our engineering processes at my company, and we're going through digital transformation at the moment. And system science and systems understanding has played a big part in that. I'm a systems engineer, so I'm a member of INCOSE, that's the professional body for systems engineers. I'm involved in several of their working groups. So the working group on healthcare, the working group on project management, systems engineering integration, and also their system science working group. And I've been giving presentations and attending conferences, and I've done a few more papers on biosystem complexity, including a paper recently on COVID and explaining how we should be using existing cardiovascular drugs to reduce the mortality. Because by taking these particular drugs, you reduce the mortality by about 60%. But it's not being pursued because there's little money in it, and there's this big push on vaccines, for instance. So, but to try and bring this discourse to an end, I gave a presentation to the ISSS about 6 years ago, and it was understanding disease with systems thinking. And then I started to get involved in the ISSS, giving presentations and listening and learning. And John gave a talk fairly early on in my involvement with that on relational theory, and I could really see the starting point of how system science could actually be used to underpin and validate our systems engineering processes and the way that we do things in systems engineering. So what my current role at the ISSS, I'm the VP for systems practice, and what I'm trying to do is I'm trying to help to integrate all of our system science knowledge into an organized framework which recognizes the value of diversity, but also provides sufficient enabling constraints for bringing all of our knowledge together as essentially a learning system. And I want to use that as a bridge for integrating our heuristics and our knowledge about how systems work and how we can engage with systems into a genuine system science, which integrates both theory and practice. So that's kind of where I am, and yeah. So sorry about the long story.
That's okay. That's very interesting. I like the kind of convoluted path that still has a theme to it.
Yeah,
it kind of fits mine also.
Yeah, that was one of the things that was coming to my mind as you were talking about it. The fact that you saw something, and then you realize something else, and then you realize something else, and then you realize something else, and all of a sudden there's this great big world of complexity around you.
Right.
Yeah. That seems to be common among systems people, to be redirected like that. And at one point in my nefarious background at I just felt, how could I ever put all this stuff together? It doesn't add up to
Right.
anything. You know, I have oil spills, I've got gorillas, you know.
Yeah. Why don't you explain a bit about your background, John, just so we've got it on record?
Well, I figure you both know me already. Anything I say will just confuse matters.
Yeah, well, you know, we might decide that this video is worth putting online for people to see. Yeah.
All right, sure. I'll never miss an opportunity to condemn myself. Well, you know, I started in physics in undergraduate at UCLA. And I guess my big shock was when I got into quantum theory, and suddenly the neat world that I was so comfortable with in classical dynamics just fell apart, because we had this uncertainty principle, and people were talking like they were philosophers, wondering whether things exist if you don't look at them. So I didn't know what had happened, you know, because I was more like Rutherford, if you know who that was. It's a physicist who was famous for saying that there's only two approaches to science. One is physics and the other is stamp collecting.
Yes, I like that. Like it. Yeah.
Well, see, I liked it too. And I was just sort of like a natural mechanic. We always repaired all of our own cars. Now I built my own house. I relate to machines really well. But after that, I said, whoa, there's something else going on. I was always afraid of biology because it was just too much stuff in it, you know, to memorize.
Yeah.
But anyway, so that led me on a different path. Instead of finishing the physics degree in particle physics, I did my last year in geophysics, and graduated in geophysics, planetary and space science. And then figured that I would continue with that. And I had a job with NOAA, and took me to a observatory in Boulder, a solar observatory. I figured, okay, now's a chance to do an advanced degree. So I started looking into a master's program. And for whatever reason, I didn't want to enter into a mainstream single discipline program. So I entered a master's program that was really designed for teachers. It just allowed you to branch out and combine courses from different disciplines. But the first one I signed up for was physics of the sun, you know, because that was where I was working. That makes sense. First day of the class, I'm sitting there and I opened this book and I literally feel sick to my stomach. And I said, I can't do this. So I dropped the class and I got to the catalog and said, well, I'm just going to go through and see what looks like it's interesting to me. And it turned out to be primatology in the anthropology department with Dr. Green. It was the greatest course I ever took. So I learned about apes and Jane Goodall and Diane Fossey, and led to eventually going out there and working in Diane Fossey's camp. And so that was a transition to ecology. And then I got totally fascinated and fell in love with ecology. So much so that it was even hard to do it until I realized that most people weren't doing ecology. They were doing the physics of ecology, which I could understand well enough to know that it was rather dime store physics that they were using, and more of a semblance than the kind of theoretical rigor that you have in physics. So I've been more oriented toward coming up with some rigorous theory that would apply to ecology. And you know, then I switched from jobs in geophysics. I was able to get different assignments because of the type of job I was in. And I got onto this environmental assessment program for the outer continental shelf, for the Alaska continental shelf, and on an oil spill research team. And because I had done a master's essentially in environmental biology, environmental ecology, I was asked to head up a component of that team that looked at the biology, because they started with a physical model of showing where oil goes, and then a chemical model of how it weathers and changes,
Mm.
And they said, well, we don't know anything about the biology. So, but that was the hardest of all, because with biological studies like that, and especially during a crisis, you really have one hand tied behind your back if you don't know the prior conditions, because things that are affected by oil might just leave, or they might all die. And by the time you get there, you don't even know they existed. So there's lots of things like that. And that was an amazing time, because it got me into the idea of a different kind of science, which was science during a crisis, and exploratory science, which is not at all emphasized in traditional disciplinary science. And then that led to systems thinking, and I was always interested in figuring out cosmology, since I started in physics, and actually I had imagined myself being an astronomer early on, but so I always wanted to know more about space-time, and I read Einstein's little pocket book on this one, in fact, on special and general relativity, if my background will allow it to be shown.
Yeah.
Anyway.
Yes.
So, I read that about 5 or 6 times and never understood it. So I've been trying to figure that out, and at some point stumbled into Rosen and relational theory, and suddenly I understood relativity, and I started working on those models and came up with the holistic theory that I felt applied best to ecology. And I just finished 2 papers with my PhD advisor, Carol Westman, now, that are in Gary Metcalf's handbook on systems science. Really going into depth about the ecological application of that, and looking at the history of modeling potentials, which ecology romanced for a while and then kind of abandoned, and then became very heuristical. So it's an argument for going back to theory. And I'll just add one more thing, because this is turning into a long story. At one point in my NOAA career, working at the Geophysical Data Center in Boulder on global change data, this is after I switched from geophysics to ecology, so I was officially a physical scientist ecologist. At one point, I realized that they didn't really want me to do ecology. They wanted me to attract money from NOAA's ecosystem programs so that they could do geophysics.
Yeah.
That's when I got out and did the PhD, which was 20 years late in completing. But one of the assignments that I got that actually shocked my bosses and caused a great deal of dismay was that, because of the things I was writing, I was asked to come help build a new center in Charleston, South Carolina, that was focused on coastal ecosystems health. It was supposed to be the center for coastal ecosystems health. And they wanted me to build the data and information component of that. So it's a great challenge and a great opportunity. So obviously I jumped on it. My boss has said, well, they must have made a mistake in picking you. But no, he said, no, I was the one he wanted.
Okay.
And it was all based on a paragraph that I wrote. He said, oh, this is visionary thinking, and we want you to take the high road, because it's one of those situations in government that happens where they got the money for political reasons. A Navy base shut down, and NOAA was going to get the base and could use it, and they didn't know what to use it for. Not the base, but a facility on the base. And so they said, okay, we're going to make it coastal ecosystems health. So they've got the money, and they have to figure out what to do. So that was an amazing thing. And this was before really getting into Rosen, but I pretty much designed it in a 3-part system that would inform the other parts of the center, which then made it a 4-part whole, which I later, discovered was the holistic theory that I got from Rosen and elsewhere. So that's my story. But I guess the last footnote there is that the Center for Coastal Ecosystems Health became the became named the Coastal Services Center because nobody could figure out what health was. So that's the question that Carl has.
So that's great. So the question, the subject you'd like us to explore is what is health, and what is that, and how does that relate to relational theory?
Yeah, that's really the fundamental question. Then there's some other subsets of that, such as the health in buildings or healthy buildings and so forth. And I just wanted to add one other thing, how I came to approach John and we got connected. I was reading Rosen's book, and when I got the book on anticipation last, and I was kind of searching through that, and I got to I believe it was the last chapter written by John. And the concluding sentence was, it's now time to apply system science. And that was not the light bulb going off. That was like a lightning stroke. So I sent him an email. And the reason I bring that up is that I'm looking at application from an application side of it rather than the theoretical side, or even from the corporate side. And it's in an area of indoor air quality, which has ignored people forever. And it's still very, very difficult to get anybody to take a look at it, even consider it. The typical reaction is, why? We haven't had a definition of health forever, and we're doing okay. So why do we need one? It's just too complex. And that kind of triggered off something from my childhood that was, oh, you're just too technical. Why do you want to do that? It's, you don't have to get that involved in things. And it's like, no, that's what we need to do. Yeah. Kind of thing. So that was I kind of bring this into a little tighter focus right now. In addition to the general definition of health, which as vice chair of a committee in ASHRAE, it's environmental influences creating environmental influences creating an effective indoor environment. And that started about 5-6 years ago, and the document talks about health. And the story how I got involved is for another time, but it was, well, here, I'll get you the unlocked PDF, get it in Word format and go through and just change it the way you think. Well, within the first 2.5 pages, I had tracked changes. It was just a mess, and it was all health related, and there was no definition. So they said, well, let's start that. So we held a couple of forums. I had a group that eventually at various times included about 70 different people from about a dozen different countries. And we wrote a report that is on our progress on health, which concludes with Rosen and system science, relational theory, and that's been accepted for a conference in Athens in September, if we make it to Athens. And then I just got word that they want me to do an expanded version of that and write a paper to go into a special journal issue the first part of next year. So that's kind of part of it. So I'm really interested in now, in particular, and the latest conversation I had with John has to do with a conference in Hawaii in November. It's by the International Society of Indoor Air Quality and Climate. And the theme is the bridge between research and practice.
Okay.
And I've made progress to where we've got at least a half day. We're pushing for a full day track on that topic for indoor air quality. And the way I'm getting people to understand, at least get their attention now, is to pick a topic that is a problem, like health in buildings, practice and research, that are incompatible. And there's a number of people a lot of PhDs out there that this is important to them and they don't know how to proceed.
Mm.
So when I present the concept that I did, like with buildings and people, of, okay, well, let's put research over here and let's put practice over there, and let's not try to integrate them.
Mm.
Let's not break down the silos. They've had several symposia and workshops and stuff like that in the past on breaking down the silos. And I finally came to the conclusion that we ought to strengthen the silos, isolate them further. Then we can get some clear vision of how are they related or not, and if so, how can they communicate back and forth to each other. And I'm getting really good response from both PhD researchers, engineering type people, and practitioners of different levels and in different parts of the industry. So when I was telling that to John and discussing it recently, that's when he suggested that you might be able to help us out on that.
Yeah, I mean, it sounds like what you were doing when you were saying you were strengthening the silos is you were making distinct the components.
That's right.
Within the system that you want to create. Yeah, we do a similar kind of thing.
Or a hold-on, as John calls them.
Yeah.
Yeah, and I wrote a very similar thing in the ecology paper that I just got out with in Gary's book, that if you look at just two aspects of a system, a realized aspect, the potential versus actual, as Aristotle put it. There's been a lot of work trying to figure out how to combine these and integrate them and conflate them. And most of our science does conflate them. So I said, no, the answer is to separate them, isolate them, make them, and do dynamic science properly as dynamic science, and don't pollute it, as Charles Hall, who's another author in that book section, was saying that, no, they're messing up real science, real dynamical science by adding all these fuzzy concepts. I said, yeah, we should do dynamics as dynamics and do the potentials as potentials. And then we need a concept of how they relate.
So how would you like to progress? I mean, what I've got in mind is perhaps we could share some models that we've been working on, and then have a conversation around those models, because I think then we'll start to see the correlations and the connections. And I mean, there's already been some things that you've said which have sparked things in my mind. But do you have some diagrams, some models you'd like to share?
I don't. That's kind of what I need.
Okay.
Because the primary attendees of this conference, and that's becoming a sharper focus, I'm on the organizing committee also, and I want to be able to have something other than just talk about this. I want to be able to, talk to John about us conducting a workshop, and while nothing is final yet on any of this, they're really interested in having that workshop. And the main discussion now is when in the conference and when in this track we present it. I'm familiar with these people, the engineering. It's most of them are engineering oriented on indoor air quality, and they do fantastic research. They are socially active, particularly with COVID. But I'm not an engineer, and I'm not a PhD. So, and they know that, but they haven't told me to sit down and shut up yet. So, in fact, they continue to include me in things. So if I'm going to present something, whatever it is, I need to be able to do it from a PhD, an academic, an engineering approach, and I can't talk their language. Just like I understand pregnancy and children and childbirth, but I've never given birth, so I have no idea how to talk to anybody about childbirth and pregnancy. Okay, so that's kind of my analogy with that. So I'm what I'm looking for, and was talking to John about, was ways to communicate in their language and their culture, so that instead of we can get beyond that's interesting, let's talk about it, to here's how we can do something. Here's how we can now take a system, an approach, an organized methodology to move beyond the talk and the wonder and the curiosity about it, to say, okay, here's our research, here's our practice. How can we, let's now do something about it. And there's a structure within Aic to do that. They have science and technology committees that, if we were to get enough interest from half a dozen people or so, there's the possibility of forming a science and technology committee on this subject.
Okay.
So it's very simple, in 5 words or less. I assume I can get an answer, right?
Yeah. Would you like me to share some of the stuff that we've been working on, John?
Yeah, absolutely. Yeah.
Okay.
I mean, you've seen my stuff. That's more theoretical.
Yeah. So I'll get to this in a minute. Carl, have you come across this way of thinking in terms of fit, form, and function in engineering?
No, I haven't.
Okay, but I'll get to this in a little while. Okay. Right. So I'll take that off. So a couple of weeks ago, I mean, this has been a long time in coming, and lots of people have contributed to this. So what I'm going to show you is not my framework really, or my architecture, but I have done a lot in pulling stuff together and having lots of conversations. What we're trying to achieve is an architecture for system science, so that we can organize our knowledge and put it into practice as a learning system. So this was my definition of architecture in terms of the spirit of what I was trying to do with what I'm going to show you. So architecting is the process of taking seamlessly diverse and previously unconnected components, taking into account multiple perspectives, and creating an integrated system with emergent properties that serve stakeholder needs. And utility is the measure of success. What I'm trying to do here is not create a pile, but create a good architecture within which we can integrate all our stuff as an actual system, a coherent system. You know, this is the problem we all face. You know, the world is far more complicated and complex for us to manage anymore, and you know, we're living in the age of the Anthropocene, where you know, we are actually changing the geological processes of the planet, and the kind of thinking and acting that's got us here is insufficient. We need new types of thinking, new ways of thinking, and new ways of collaborating. There's lots of good stuff that's going on at the moment, and this is just a few of them. But if we all came together as in a more coherent way, actually backed up by a science, rather than just heuristics, we could do an awful lot more. What's system science about? It's about essentially it's about everywhere and everything, essentially. So systems are everywhere and everything. And you know, you've got the human civilization system, social systems, ecosystems, solar systems, cosmological systems, biological systems. You know, every single thing is a system. The idea with system science is that there are general concepts and patterns and principles that span across all different kinds of expertise and experience. And potentially, because of that premise, we could have a common language and framework for thinking and acting across disciplines, which could allow us to better collaborate, appreciate, and address our grand challenges. The science that we need is it's a study of 2 dimensions, and these 2 dimensions need to be brought together as a coherent whole. It's our engagement with systems, our systems thinking, acting, and engineering, and also our foundational knowledge about the nature of systems. And to some extent, there's been a are moving apart on these two dimensions, and we need to bring it together. The framework, the architecture needs to be capable of integrating all of our system knowledge from diverse systems domains, and also, I guess you could say, tribes of systems thought and acting. This is a great model from Dave Snowden that I encountered about 7 or 8 years ago, and I found this really helpful for helping me to understand situational context, the perceived chaotic, the perceived complex, the perceived complicated, and the perceived obvious. And the reason why this resonated with me so strongly is I could actually see how it related to our engineering processes, our systems engineering processes. Traditional engineering has really been focused on the complicated and the obvious. So good practice and best practice. But when you engage in really complex systems, you need emergent practice, and novel practice is really where we're dealing with situations that we've just not encountered before. So this is in terms of engineering processes, this is where we do our conceptualization, trying to identify systems, to look at relationships between systems, to start to move away from disorder and start to at least identify the systems. The next step in our engineering is our architecture, and architecture is where we start to organize stuff, and where we start to appreciate systems in terms of their wholeness, so their features, their functions, and their qualities. And we use architectures as the enabling constraints for our designs. So we design within architectures, and this is where we bring together all of the experts and the expertise, and this is where we work out how the systems are going to be realized. And then when we implement our designs, when we make them real, they become obvious. But the thing is, when you implement a system into an environment, there's almost always some surprise, and there's some degree of again, there's a new situation that arises. So that this was a really useful framework for understanding. Another example of the power of frameworks is with chemistry, where we had the symbols of the alchemists, this was basically a mix of stuff. Some of these things were genuine elements, some of them were mixtures, some of them were compounds, and other stuff like magnetism. And it was our heuristic practices of alchemy were brought into an actual science of chemistry when we started to be able to organize stuff, and make distinctions about what is what. So we moved from mystery to mastery when we moved from alchemy to chemistry, and the periodic table was a great enabler for that. And I see a parallel with what we do in systems engineering at the moment, which is to a degree alsystemy. We don't have a science yet that backs it up. But with system science, I think we can move to systemery. So in the future, the systemist would use their understanding of systemics when they manipulate and transform systems. So that's what I'm really hoping we can bring about. I gave this slide to the ISSS community about 1.5 years ago, and I explained that where we were at the moment was essentially in disorder, because we didn't have a common vocabulary. We didn't have a shared orientation in terms of a framework for organizing ourselves. If we had these things, we would be better at collaborating, and we would be better in terms of actually getting out there and doing good through our practices. Now, this is where we start. So one dimension of our foundations for our system science is relational theory. And really, this is over to you, John, really, but I've had a conversation with Bill Smith recently and started to try and get a better understanding of his AIC in the context of this model. So here we have the whole system, but also we have disorder. The from that disorder, relationships start to come into existence between data, and then that data that disordered data, then when the relationships start to form, you start to get information. Once the next step is that information then starts to become structured either physically or conceptually, and then that becomes knowledge. So you're now able to appreciate that relationship. The next step is, within those enabling constraints, with that knowledge, you're now able to exhibit forces. So the relationship is now an influence. And then the next quadrant is matter and energy, because your forces are now essentially creating and actually transforming mass and energy. So the relationship is now control. So that was my interpretation of Bill's AIC on the overall model. And I know that I've probably not done it a real justice, but I think that that this relational theory, this is the reason why we see all these diverse 4-quadrant frameworks for understanding the nature of systems and existence. So ODA, observe, orient, decide, and act, the kind of thing model, which I showed you previously, panarchy, the unbroken sequence of origins, and many more of these quadrant frameworks. So John, would you like to explain a little bit more about that and put right all of the things I said that were wrong?
Well, wait a minute. Now, first of all, I don't know right and wrong. But yeah, I mean, I'm trying to do something very similar where, I'm very interested in Bill's approach, and because it is very similar. I've been trying to convince him to go to a 4-part ontology instead of a 3-part. And he kind of agrees, but he keeps leaving out, what you have labeled here is the mass, energy, the state, the system, the existence part. He says, well, yeah, of course it's about that. The problem is we've always taken that for granted. And most people don't realize that quadrant is just as causal as the others. And, and as you're showing here, that quadrant is what leads to, through structures, leads to a meaningful interpretation and, a new model that expresses new possibilities in new context. So that's rising on the right-hand side there. I only really have a couple of comments here. One is that I tend to associate information with both the functional and structural functors, the F and the S on the horizon, in the middle there, because that's like that's the glue that holds the incompatible hemispheres together. We don't have any logical entailment between those two categories. We have that's where you find relations. The F and S are the relations in the diagram. And I think I could probably change my label instead of, or I put knowledge on both of them. You could say information parentheses structure, and then information or knowledge on the other side, because what's happening on the right side is it's information, just as you've said, that's going, because it's the material pattern that's been created informing a new context. And so it's a informing rather than a thing called information. And on the other side, it's the new model providing some kind of boundary condition on the dynamics, the forces.
Yeah.
And so, and if you consider models intelligent, I mean, that's reasonable to call that knowledge. So I think I hadn't thought of this before, but I think information on the right and knowledge on the left, but I consider both of them as being information functors.
Yeah.
The other thing I would say is, in mapping Bill's framework onto this, I tend to put appreciation in the upper right, and then I put influence on the upper left because the formal cause influences the organization of forces.
Mm.
You know, it's not a direct cause, it's not a rigid or
Yeah.
one-to-one causality.
Yeah. Yeah.
And then the forces then become control,
Yeah.
because they are an exact expression of what happens in
Yeah.
the existence quadrant, or whatever you want to call that lower
Yeah.
right.
Yeah. Yeah, we
That's
could do
where
it like that.
yeah, that's where how I would map Bill's
Yeah.
thing.
Yeah. Yeah. The reason why I mean, I'm completely open to changing, you know, where we put these. This was what was kind of going on in my mind. What I see. So I see information relating to concepts. I'm talking about, you know, again, you know, our real world. I don't know, our engineering experience. I'll just go like that. You know, here we've got our concepts. Our concepts are then brought together into models. So now this is the knowledge of know what, yeah, and down here we have the knowledge of know how. So this is how we can change stuff. This is our knowledge of know how here, and then when we apply our know how, we have our real systems. And in this world, the material world, and this is the world where we hopefully develop some wisdom, yeah. And we have our, not only in our repository our know what and our know how, but we also have an understanding of know when, and know who, and when not to do stuff, and when we should do stuff.
Yeah, I just see that lower right quadrant as being patterns, either patterns in space or patterns in time, or both. It's like the result of everything. So so I would just rotate Bill's labels, you know, one quadrant,
move them around
clockwise.
Yeah.
But now, what do you have on the top for Bill? What's the upper right as far as Bill's framework, the way you currently have it?
What I've currently got here
Oh,
is
existence.
yeah.
Okay, but see, that's this. You've got existence in the mind there, and it's. We're talking more about existence in the world. You know?
Yeah. No,
it's not wrong to rotate them. You know, in fact, that's how I got the 4 life types. You know, these things, you rotate it and you get a different kind of system.
Yeah.
So, you know, you're okay to do this, but it has a very different implication.
Okay, Carl, do you have any thoughts on what we've been talking about so far? Any questions you'd like to ask?
The details that the two of you have been just discussing is a little out of my league here. But what I like about this is that it's something concrete that could be presented to these engineers and researchers to say, although this is new to them, there is a history to it. It's solid, it's science-based, and here's a conceptual understanding of it that I really like with this and the previous diagram, to be quite honest, the two of them, as a leaping off point, like in a workshop, to say, okay, now here's a situation that you all encounter that has components of it that you are interested in. You know it's important, but you can't, you don't know how to move forward, or you keep meeting obstacles. So in a workshop setting, it would be, how do we, this is too complex to do that, but if they're to give them the conceptual model and then work them through a process on a particular issue. And that's where I see the possibility. When I see this in the description and so forth, I get real excited, because it's like, God, there's maybe a way to do this.
Okay.
I would be a little careful saying it's science-based. Not that I don't like that, but that people might object. It might be more accurate to say it's logic and mathematics based
Okay, yeah.
in a framework. It's really a meta model. And what would you say about that, Gary?
What is science?
Well, I would.
So here we go. This is science.
Okay.
So what I've done is there seem to be lots of different interpretations of the scientific method. Yeah, but David Rousseau identified Gauche and his witnesses to successful science. And what I've now done is I've taken this relational framework and now I've related it to the nature of science itself. Yeah. So you've got the 5 again. Yeah. So we have ideas, so new concepts and hypotheses that expand our thinking, and we use these to create our general frameworks, our models for understanding nature and the world. Yeah. Within these frameworks, these provide the enabling constraints with increasingly specific and comprehensive theories from which we can develop our principles. And then when we apply our principles, we can have reproducible experiments and results. And we can also use these principles to create assets. So these are our science-based technologies that work. And then we place our assets into the greater whole, which is nature and society. And our frameworks also provide steadily improving predictions, often unambiguous, precise, diverse, and even surprising about nature and society. And then working back, we have interlocking evidence of diverse sorts, which we can use to, as a feedback into our principles in terms of making sure that our principles actually deliver the results that we expect.
This might be a good diagram this might be a good way to address the question of science-based.
Yes.
I would say this is what I mean when I say it's science-based.
Yeah. So we've been developing, what relational theory is a framework based on ideas and concepts. Yeah. And I think you're on the cusp of actually creating mathematical proofs of that, which is,
well, Aloysius Louis has already done that.
Okay.
But,
so I would say
he hasn't gone into the holon, which I would like to get him to do.
Yeah. So I would say that what that previous diagram, I would say, is science-based. Yeah. I think we have a justification for that.
Yeah, but see, Aloysius Louis is a mathematician, so he's showing and all science has no proofs.
Yeah.
It's all mathematics has proofs.
Yeah. But we can validate our frameworks in terms of the practice as well.
Okay.
What the reason why that framework is so attractive to me is again because we can see diverse heuristic frameworks which actually map onto it. So for me, that's a validation.
Yeah.
The 4 noble causes of Buddhism. There's all sorts of different frameworks which fit onto that, including Aristotle's 4 causes as well. So both classical, philosophical, engineering, there are many heuristic frameworks which map onto relational theory. So for me, that's a great validation.
Yeah, absolutely. I'm totally in agreement with that, and I consider it part of science as well. It's just that from interacting with people who could get critical if I stayed up front that this is really a meta level of science.
Yeah,
it sort of cuts them off at the knees,
Yeah,
they can't come.
Yeah, it is a meta science, but it is also a science in its own right.
Well, let's just call it a meta level of science. So it is science, but it's at the framework level.
Yeah,
it's a methodology using a scientific type method.
It's the organization of science.
Organization of science.
Yeah.
So I'm particularly attracted to the frameworks box here, looking at, if I were talking to researchers, academic engineers, so forth, and say, of all the is there any part of of your scientific method, your organized methodology, that is maybe left out of this? I would say it would be the framework.
Mm-hmm.
And that framework, and I'd like your thoughts on this, is that the doorway to the system science? Is that the doorway to relational theory? The part that's being missed, and that if they were to look at the frameworks from a relational theory point, that's what open up the door to what the additional things they want to know, the mystery.
Yes. Yeah. I agree. So I'm encountering something similar in our systems engineering. You know, we have heuristic principles and processes for doing systems transformation, but we don't have scientific based frameworks that we can hook our stuff into. So we know this stuff by and large works. It doesn't work all the time because we're often not allowed to do the things that we know we should be doing at the right time, and they bite us in the bum later. What I'm hoping with systems engineering is that by hooking our stuff to a scientific framework, we will have more justification for doing the right things at the right time. Because and you probably encounter this as well, Carl, in your domain. When you don't do the right stuff at the right time, you pay a big price for it later on.
Right. And in a very concrete way, you go into like what John was talking about earlier, like in crisis science, or the oil spills, or in indoor environmental issues, fires, floods, hurricanes, mold, all the types of things that go on in the buildings that are built for one climate, and then they just transfer them to a new climate that's incompatible.
Yes.
And if they don't pay attention to those kinds of things, they create problems rather than solve problems.
Yeah. No, I can appreciate that. I was an architect of a border security system, and the system was deployed into a very hot, dry environment, i.e. desert-like. Yeah, and the equipment doesn't like it.
Right. Yes.
Yeah, so you know, the overall idea is data, information, knowledge, power for a wiser world is essentially the intent. Yeah. And again, relating it back to the Kineman model, which I think is it resonates with engineers at least. Yeah. You know, working out why, working out what, working out how, and then establishing the common wisdom. You know, information and observation, knowledge and architectures, power, design, forces, and then the realization, you know, with the transformation of the energy and mass. So our ideas, our frameworks, our principles, and our assets for engagement in nature and society as a greater living whole. That's the overall intent. Now, the other dimension is knowledge categories. And there was, so David Rousseau-Julie and Javier came up with these set of knowledge categories based on philosophical categories. And I saw this a couple of years ago, and again, I saw the potential utility of this, but I've adapted it a little bit. So I've changed. So they had identity, character, life cycles, capability, values, and learning. And I've changed character to behavior because the behavior of systems is so important, and it's also more distinctive as a category when it's analyzed in terms of its related concepts. And the other one I've changed is I've changed learning to experience and consciousness, because not all systems learn, but all systems have an experience. So this category has more utility. Now, when we take these knowledge categories and we place them in the context of the life cycle, we now get a matrix. So here we have our concepts, our ideas for observing. So these are the concepts, the key words that we use, and these aren't. This isn't necessarily going to be right. This is an example of the kind of information that would go in here. Okay, but it's probably pretty good. Yeah. So regarding identity and the togetherness of things, these are the words that we use, the key concepts for observing and communicating about identity. So structure, components, boundaries, boundedness, form, wholeness, integrity, network, and topology. Those kind of words. And then when we use, we have another set of words for describing behavior and the relationship of things. So things like activity, dynamics, influences, interactions, dependencies, feedback, source, sinks, stocks, flows, effects, leverage. So these are the concepts related to behavior and the relationship of things. In cycles and the phases of things, we've got inception, growth, life cycle, maturation, death, decay, states, phases, transitions, tipping points, those kind of concepts. Capabilities and the purpose of things, stakeholder, responsibility, function, role, hierarchy, autonomy, environment. Now we get into value and the qualities of things. So perspective, judgment, condition, circumstances, fitness, benefit, use, selection, and someone suggested feedback recently, so I added that in there. And then consciousness and the experience of things. So awareness, understanding, empathy, comprehension, learning, history, memory, evolution, adaptation, and anticipation. So those are the concepts, you know, the words that we use, and here we would have our framework. So these would be our models for understanding. So theories of identity and togetherness, theories of behavior and relationships, theories of cycles and phases, theories of capability and purpose, of value and qualities, and theories of consciousness and experience. So this is where those theories would be placed into the framework. Remember, this framework is about organizing our systems knowledge about systems and how we engage with systems. Then we've got big ideas. So these are just suggestions, but these are the kind of things that would be developed from these frameworks. So knowledge and principles that, for instance, simpler things combine into more complex things. So that would be about identity and togetherness. In behavior, very different things do many things in the same fashion. And we can see this in nature, where nature has developed different, I don't know, what's the word, different forms have the same kind of behavior. I guess that's one way of expressing that. Everything follows a life cycle, even the universe. Emergent properties, you get emergent properties when things combine. Value increases when stakeholders are engaged. And the more complex something is, the richer is its experience. And when we apply these principles, these are the assets that we create. So when we apply these things, we get resources, we get processes, empowerment for decision making, our abilities, our achievements, and our wisdom. So this is essentially a knowledge of what is possible, and you know, the transverse of that is opportunity. So this is how these things then interact with the greater whole. Yeah. So with wisdom comes the world of possibilities. With achievements comes opportunity. With ability comes utility. With empowerment, there's a cost. With processes, there's a reaction. And with resources, you create domains. Now, I mentioned form, fit, and function. These are very important concepts historically in engineering. And I realized this relationship just a few weeks ago, but it's starting to really reveal its power. So form is essentially the combination of identity and behavior. So this is the form of things. The fit is the fit of the things in the wider environment, because every system is also a subsystem. So fitness is determined by the environment. And function, what I'm starting to realize is function is essentially a conversation between form and fitness. And there's a side of function which is related to cycles and the phases of things, and there's another part which is capability and the purpose of things. And what I explained to in conversation the other day with one of my colleagues is that you know, myself as a system, my form, my identity and behavior, yeah, I'm part of many systems, yeah. You know, my family, my work, the ISSS, you know, all sorts of different systems that I engage with, and my purpose is and my function is a conversation of myself and my environment. My fitness is judged by the systems that I work within, and my capability, and to a degree my life cycle and my states and my function is a conversation between myself and my wider environment. And I think that might have potentially some utility in our discussion about health, yeah, because the health of the system is its capability to serve in the systems within which it exists. And maybe that might be worth us stopping for a moment before we move on and having a conversation about that.
Yeah. This may be jumping a little bit. How would I, this or some other part of the presentation, as you were talking about this, it suddenly dawned on me. There is one very critical issue that is a hot topic with this organization. And it has to do with COVID. And, you know, the theme is bridging research and practice in the age of COVID. Okay. The indoor air quality engineers and others have been pushing for almost the whole year now about the importance of ventilation rather than fomites in the transmission of the virus. And they are not being heard in certain key areas. They even gathered together over 100 of them who signed a paper saying this, and they still aren't getting the traction they need, like with CDC and WHO and school districts, property managers.
Yeah.
So I'm looking at how would this systems theory, the science and relational theory, how would that help them? Is there something within this matrix that you just described that they could take that, we could take that and say, look at this and this and this?
I think so. I need to build up the story, but I've got something explicit which I think will help.
Okay.
So Bill Smith that we mentioned earlier has got something which he calls the AIC theory. I think it's appreciation, influence, and control. And when you multiply up his theory to the next dimension, 9 powers are revealed, and these are the powers. These are powers that you can utilize in systems transformation. Yeah, and the 9 powers map again onto kind of in the overall framework in this way. So you've got the power of spirit and living, which is something that can support you in conceptualizing. There's the power of philosophy, which supports the power of, it supports illuminating information, concepts, and theories. You've got the power of research, which is where you're building up new mental models and new architectures. You've got the power of technical, which is the bridge between architecting and design. You've got the power of, and this is the intended act, which is where you're dealing with the complicated. You've then got the power of decision making, the power of design aesthetics, which has an influence on social, and then you've got the political power, which is essentially the thing which helps to spin it all around. Yeah, so these are the 9 powers. And Bill did his PhD after his work with the World Bank, and his thinking about transformations in that particular context. But this is again, very useful. And the reason why I found this useful is we can now start to connect the practice of engagement with the knowledge about systems. So this is knowledge about systems. And now we can start to engage with the with the practice. Now, when we did a workshop with the ISSS a couple of years ago, and this
can
was
you go back to the previous slide, please?
Yeah, sure. That one, yeah.
Yeah, that one, yeah.
Okay, yeah.
So I just want to take that in for a moment here.
Yeah. So
okay, so
this knowledge about systems that sits behind these things, yeah, this knowledge can be an enabler for these powers. Yeah. So our theories of value and qualities and our theories of consciousness and experience can help us with the engagement with the spirit living power. Yeah. Our knowledge of cycles and phases and capabilities and purpose and these kind of principles can help us to engage the political power. These things here can help with the engagement of the technical power. In terms of the intended act, our understanding of resources and processes and these kind of principles can help us with our planning for action. Yeah. These assets and these principles help us potentially with decision making and in deciding, what is a good design. Yeah. It is enabled by this knowledge. Our understanding of past performance, for instance, and our wisdom can help us to design better solutions.
I really like this. Yeah. Okay.
Yeah. The utility starts to come forward even more explicitly as we go forward. There's
Does this mean that theories of value and quality don't enter into politics?
Well, one way of thinking about this is nearness. Yeah. I'm sure they would. Yeah.
Okay.
But yeah, there's this is more complicated than I'm showing. Yeah.
No, I can see how to do that. I can see how to deal with the nearness idea.
Yeah.
If you're thinking of it that way, then
yeah.
I can
Bill talks about these things in terms of fields. Yeah. So
like, for instance, in my way of thinking, of course, you have the semblance here of a hold-on structure. And if you look at, say, just take political in the middle as the main one in this case, I think the whole diagram could be resorted 9 ways to put each one of them in the middle. But anyway.
Yeah, and I think that's consistent with Bill's thinking as well, actually.
Okay. So if you look at the politicals as the middle, then you have 4 quadrants. Forget the labels for a minute. Let's assume that they make sense to you as far as the 4 causes. Then the lower left, where I asked the question, theories of capability and purpose fitting into political. And I was saying, well, does that exclude then theories of value and quality? No. Theories of capability and purpose is 1 quadrant. In the hold-on analysis, every quadrant is also whole. So the wholeness of that theories of capability and purpose would be the spirit living quadrant that you're showing in the left. Whether the labels are correct or not, I'm just talking about the structure of it. But it looks like at some general level that the labels would work as well.
Yeah.
So like each one is whole. And that leads to another comment that I had, which is kind of a random thing, but in the column there at the top, in the middle, where it says simpler things combined into more complex things, where does that statement come from?
You mean in terms of logic or its heritage?
Oh, yeah. I mean, why write that particular sentence?
Because we've been having conversations on the essentially the nature of systems emergence and all of these different levels, these grand, what Tyler Volt calls the grand sequence.
Yeah.
So this comes back to this diagram here. Yeah, simpler things combine into more complex things. That's essentially this. This is part of our. This would be part of our theory of identity and togetherness. Yeah.
Okay, I get it.
Yeah.
Yeah. Okay, so go back to that one then. So then, if that's thought of as the four parts of the technical aspect,
Yeah.
it's kind of, see, we have theories of identity together, there's theories of behavior, very different things do many things. So then you have multiplicity of effects, basically results.
Mm.
So this is kind of the thinking quadrant.
That's
of
right.
that
Yes.
technical thing, in which case I would suggest a modification to include a broader range of thinking.
Mm.
What I would suggest is that complex things combine into more complex things, or reduce to simple things. Now that's personal. That's parochial. That's the way I see the world through a whole on thinking, but it does include both cases, the simple and the complex.
Yes, because simple things are also complex.
Exactly. So,
Yes.
and in fact, where the whole on theory has gone is that the world is complex, and it's so easy to explain so much in standard physics, for example, by seeing that the complex reduces to what we think is a simple system.
Yeah, yeah, and then you get down to quanta, and
so
suddenly
it puts
things become
complexity
incredibly complex again.
Yeah, it puts complexity at the foundation, whereas, as you know, the classical thinking has been that we have, billiard balls at the foundation, and then somehow some magic occurs and they all become complex.
Yes,
which is basically impossible.
Yeah, I agree. Every single system is complex. Yeah.
So if the sentence reflects that complexity is the foundation, and it can become more complex, which happens in life, or it can simplify into a mechanism, which happens, of course, in almost everything we encounter in the physical world.
Could we say complex things combine into even more complex things?
I would, complex things combine into even more complex things.
Okay.
Or reduce to simple things. Because you have to have the simple.
You
have to have the simple thing in there, because it's what we bump into.
Yeah, I'll leave it for now.
Anyway.
So do the simple things actually exist? I don't know of very many things in real life that are really simple. To me, what I see as simple, is
you'll never get away with it.
Simplification.
You'll never get away with it in mainstream science, but Rosen says no, they don't exist. But I mean, what does exist mean? I mean, yes and no, because clearly we interact with something as a simple system, and to the extent that we can interact with it, it exists as that. It's just that it's got more to it, as Gary said.
This has the potential to send you crazy, this stuff. I know.
But I would just suggest that instead of putting simple things at the foundation, I would put complex things at the foundation, however you do it.
No, I agree. I do agree.
What I like about this, the combination of those two diagrams too, is that to me anyway, it's showing that everything is or can be related to just about everything else. Some are direct and some are through 2 or 3 steps. But there is a pathway from, say, research to social, just to pick out the spirit and living, to the action, to the decisions and so forth. There is a relationship there.
Okay.
And what Gary's done here, Carl, is very very much in sync with the idea of a holarchy that I have in the holon theory. You know, I've spent a lot of time just staring at one cycle and maybe showing how two cycles relate to each other through the different quadrants and things like that. And you can do a lot with that, but it implies that there is an infinite interconnection of holon cycles all through nature. And so here, if you interpret it that way, which it sounds from what Gary was saying that he could, that each of the 9 points on the holon can be thought of as its own holon.
Yes.
And that's getting at the holarchy idea. I want to look at the 9 and say, okay, are those, yeah, those are in some sense archetypal, you know, elements of a whole. So there's some basis for saying that the 9 is also fundamental.
Yeah. Okay, so I'll
Okay.
continue the story because there's a lot more here. So we did a workshop on systems literacy a couple of years ago, and there were about 40-50 people there from all sorts of different walks of life and stuff, and we asked them 2 questions. So what are the features you associate with being non-systemic, and what are the features you associate with being systemic? And the non-systemic ones we clustered up into these 12 clusters, and I'm essentially now considering these to be systemic pathologies. So we've got chaos and conflict, perspective gap, no vision of the future situation, not seeing the connection flow of causality, lack of information, knowledge, appreciation, unintended consequences, you know, all of this kind of stuff. Yeah. And we see this, you know, in our everyday world and also in the projects that we engage in. Now, what we now do is we now place those systems pathologies onto the framework.
Oh, that's cool.
Yeah, and you can see how the utilization of these powers can be utilized to address these system pathologies. Yeah, so when you've got limited choices, you can do stuff using the technical power and the action, you know, the intended action power to extend your choices. You can address resource and energy gap with decisions and with an intended act. The wrong direction can be addressed by making better decisions or through the political power. So we've placed the pathologies in between the powers, and what I've also done in this Kumu diagram.
Did Len contribute to this at all?
He's seen it. He's seen it. Yeah.
And then okay.
Yeah.
I understand.
we had a rich conversation. It was actually very helpful. But then Len doesn't necessarily agree with everything that's here. So what we've got here is this is a Kumu diagram, which is a modeling tool. It's free to use. You don't have to download anything. It's really helpful and it's good for collaboration. So what we've got here is on the edges and the corners, we've got the powers. In the middle, we've got the pathologies. So these little orange dots. And what I've done with the help of quite a few people is we've mapped on the heuristics from many different systems thinking and acting frameworks. So we've got systems thinking made simple from the Cabreras, and these actually rate, I think, well to these 4 quadrants. We've got the ways of the systems thinker from the systems thinking playbook. So these are the red dots. The attitudes of the systems thinker from a little booklet that Bridget, Daniel Allegro and I did a few years ago on exploring the branches of the systems landscape. So these are the attitudes of the systems thinker. So they've been mapped in. We've got the habits of the systems thinker from the Waters Foundation, and they've got, again, some really great stuff. The 8 dimensions of systems intelligence from Being Better, which is a book from a group in Finland, which again is really great. We've got the Eightfold Path from Buddhism. So these are the purple ones that are mapped on. We've got the behaviors of the systems thinker from the UK apprenticeship scheme, and their assessment of systems thinking capabilities. The School of Systems Change, systemic practices. I can't remember the influence for this, but I think it came from systems dynamics, and again, that's really good stuff. A new pathway for understanding systems thinking. Complexity thinking from INCOSI. They have an INCOSI working group on complexity, and they come up with a number of heuristics for dealing with complexity. So those have been mapped in. And there was also a recent talk on at the ISSS on ethical regulators and super ethical systems, which was looking at the utilization of AI to reinforce essentially positive pathways and ethical systemicity, for want of a better word. But so all of that stuff has been mapped on, and that
what decides where the dots go?
It's judgment and intuition, really. I mean, you'll see, and I'm not saying that we place the dots perfectly, but again, it's probably 80% right, yeah. But what you can do is when you look at those pathways, you can start to appreciate what those pathways actually are, and that's what we've got here. So when you're in chaos and conflict, you can generate hypotheses and enable the power of research. When you have a perspective gap, you can change your mind, or you can open your mind with philosophy. When there's no vision of the future situation, you can find your place and purpose with philosophy, or you could give voice to future possibilities and engage the political power. When you're not seeing the connection flow of causality, you can make the dynamics explicit, or you can plan ahead and again engage the political power. When you have a lack of information, knowledge, and appreciation, you can develop your system knowledge, engaging the social power, or you could engage stakeholders with the political power, steering the right direction with decisions. So these are what we consider to be the positive pathways, and we've mapped the heuristics to this. It's still, of course, open to change, but this is just the framework of what is possible. Yeah. Okay. So when I showed this to a colleague at work, he said that's great. What about all of the negative pathways? So myself and Kerry Turner, we then did this. So these are the negative pathways where you have, I don't know, the abuse of power or the not use of the power, and these are the things that sustain the pathologies. So manipulation of research by funders, jumping to technological conclusions, a lack of innovation, getting lost in the data, manipulation of the information to hide, downplay the consequences, reluctance to change, to retain the establishment. And this is perhaps coming round to what you were just talking about, Carl, this particular pathway. Manipulation of relationships to blame the other, discriminating against a subgroup or an alien, benefits for the parts or not the whole, leaders escaping accountability, wasting time and effort, not enough understanding, not learning from mistakes, scope too narrow, tribal behavior, belief in unrestrained growth, competition over collaboration, lacking in authenticity and empathy, fear of the unknown, all of that kind of stuff. So
let me ask you a question. Again, following on the idea of the 4-quadrant framework, can this thing wrap? In other words, is there an arrow from the decisions on the right, pointing to the right, and coming into philosophy on the left?
Going over there, maybe.
That would be
to make this more of
consistent.
a sphere, yeah.
Yeah, it's basically and also the top, bottom, and the corners as well.
Yeah, Yeah.
So that would make it a whole.
Yes. Yeah, that's a really good point, John. How do we show that? No, that's a really good idea.
See if it works.
That's a really good idea. Oh, what we could do is we could create different variations of this diagram with different things in the center.
No,
And then you,
it does seem to work, because I look at action and spirit.
yeah,
Those would be diagonals on the holon, and research and design. Similarly, those are related, but as it's shown, they're very far apart.
mm,
That would put them.
yeah,
That would relate them.
yeah. No, I like it.
Interesting.
Well, okay. That's blown my mind again.
Technical, social.
Yeah,
Those link.
yeah,
philosophy,
yeah.
decisions.
You're right.
Yeah.
Yeah, yeah.
I also see this, and if I see something going wrong, like say with COVID again, or if I want to write an article about something, I could see like manipulation of research by funders, or even manipulation of research by marketing, by people that make products and services. I can go in here and look at this and say, okay, so that leads to chaos and conflict. The jumping to technological conclusions from the technical side. What are the different relationships that could help me formulate
Yes.
a clear description of what's happening to communicate that?
Yeah.
And also to help when I run into an obstacle, or I just can't get past a certain point, this could help me see relationships to break through that and say, oh, there it is. That's something I can look at.
Yeah, absolutely.
I like this, Gary, and you've done a lot of really good work in getting the labels to work and to be compatible with each other. As I look at the idea of linking them, as I was saying, and in a circular way. So, like, take the bottom one, social. You have complacency, belief in unrestrained growth, tribal behavior, and then the fourth one would become a false technology, a false belief in technology.
Yes, love it. Yeah.
It works, and that works for the technological cycle as well.
Yeah. Okay.
Well, when you first showed the clouds, I was going to make the sarcastic comment of you had something really clear and then you just made it cloudy, but but I like those clouds in there now.
Okay. Yeah. Well, one of my heroes is a guy called Kevin Forsberg, and I hope he sees this. But Kevin ran a training course for systems engineers that I attended about 10 years ago. And he said that one of the primary things that he says, I don't think I've seen this written down, but he said one of the primary things for a systems engineer to do is to clear the fog. Yeah. So that works. That works for me.
Well, Gary, those last two diagrams there are, I would say, almost textbook examples of what we talked about in the holon theory and in Mary's book, as to how you build it out to a network, and that you have to struggle with the right labels to make each whole make sense as a whole. But they do. You've done that.
Okay.
Good on you.
Thanks. I really appreciate that. This gets more and more for me. This gets more and more surprising and pleasing as you go through. So what I then started to do, and I shouldn't say because there were lots of people to do this. What we did is we started to look at some of the other frameworks and how they map. So we've got Taoism and the Tao and the Tai Chi Ching, and the 81 essentially principles, poems in that particular work, and those things map onto the framework. So and I think you're probably more familiar with this than I am, John, but when we map the DAO onto the framework, you can see this. The correlation is really nice. Yeah. So research is the beginning of power. Journeying through and naming the myriad patterns of the past. Philosophy is holding to the center and gendering through complementarity. And spirit living is transcending decline, avoiding excess. Social is using emptiness, remaining calm and clear to ensure that the capacity for appropriateness is renewed. Political is mastering the paradox, understanding appropriateness. Technical is the power in desirelessness, self-organizing of myriad things. Action is nature's way, acting silently, non-competitively and non-directively. Decisions is directing the power, redistributing from those who have to those who have not. And design is the evolved way, doing without undoing. And you can see how these other things
Doing
map on
without
fairly
what?
well to the clouds as well.
The evolved way is doing without what?
Without outdoing.
What does that mean?
I don't know. It's a poem.
Oh, okay.
I can read it to you if you like.
I thought it meant doing without undoing.
I've got it. Where is it? Oh, here. So this is 81. Okay, let me read you 81. So the evolved way. Sincere words are not embellished. Embellished words are not sincere. Those who are good are not defensive. Those who are defensive are not good. Those who know are not erudite. Those who are erudite do not know. Evolved individuals do not accumulate. The more they do for others, the more they gain. The more they give to others, the more they possess. The nature of Tao is to serve without spoiling. The Tao of evolved individuals is to act without contending.
God, it didn't use the word outdoing, did it?
No, I think I took that from another source, because there are many interpretations of these statements, and actually this is all translated from the Chinese original as well.
Oh, I just didn't know the word. That's all.
Yeah.
There was a word earlier.
Do you think they should be undoing? Doing?
I don't know. We
I'll have to have a
speak,
look. I'll check that I haven't got it wrong.
We actually speak a different language because you're more with the British. I saw in the earlier diagram, I saw the term blinkering, and I go, oh, that has to be a UK thing.
Okay, yeah. It might just be my terrible use of English, because I really am an engineer.
It sounds very British.
I'm glad you said that, John. I noticed that word too, and
Where was that?
I love it. I love the word. It sounds very British.
Being blinkered. No, it's right.
Blinkered,
Being blinkered. Yeah, that is right. Blinkered. Yeah.
Like blinded to possibilities, but blinkered. Yeah.
No, it comes from horse racing. They put the blinkers on the horses.
Yeah.
Well,
see, we call them blinders.
Being blinded.
Yeah.
As in cheeky blinders.
Well, I don't know what that is.
Yeah. The personality types. So I know people have a downer on Myers-Briggs because they say it's pseudoscience and not scientific, but it's actually useful. I found it useful, and many of my colleagues find it useful as well. So the extroversion, introversion, sensing, intuition, judging, perceiving, thinking, feeling, these different character traits, these again map on really nicely onto the pathways. So the thinker is supporting these pathways, the mastermind is supporting these, the idealist, the counselor, the giver, the champion, the commander, the visionary, the craftsman, the inspector, the composer, the nurturer, the provider, the performer, the supervisor, and the doer. Yeah,
they sound very similar to the Keirsey types. You ought to take a look at David Keirsey just for a point of comparison.
Could you send me could you send me a link by email? And
I'll do that. Yeah. I haven't. They have some gripe about Myers-Briggs stealing their stuff. So it it doesn't mean they're different. It could mean that they're the same.
Yeah, yeah. But the thing that what this speaks to me is that you know, nature has nurtured us as a species to live in complexity, you know, I guess nobody can be good at everything, but this is essentially a way of us forming social systems to better deal with complexity in systems. You know, this is why, this is the power of teamwork. Yeah. And this leads on to Belbin as well. So Meredith Belbin did, he looked at team roles and the different roles that were necessary to be had in a successful teams. And again, the Belbin roles map onto the framework as well. But what seems to be missing is the philosopher and the dreamer. Yeah.
Yeah,
And
I think Kirsty has that.
okay. Good.
I'll look and see.
Right. Systems process theory. I've mapped Len's stuff onto this as well. He has a systems process theory. What he's been doing, he's been collecting and organizing what he considers to be nature's processes, the way that nature basically does its system stuff. And one of the ways he organized his system processes was into what he calls these rules. So rules of beginnings, constancy, identity, rules of form, rules of scale, rules of change, rules of adjustment, rules of supply, and rules of tempo. And again, I think these map fairly well onto the framework. And what I also did was I then took his system process clusters and again mapped them onto the framework. And you know, this again, I'm sure this is far from perfect, but it gives some idea about how nature does its stuff as well, with emergence processes, possibility processes, diversification processes, and processes of sustainment and decay.
You almost need to make these diagrams three-dimensional.
Right, yes.
That way that you could get your loops from side to side that John was talking about.
Yeah, it'd be a little hard to look at though, but no.
Right. Well, we just rotate it.
So it would become a sphere.
Yeah.
You just draw this on a sphere and add the other arrows.
And when you get it complete enough, it begins to resonate, self-resonate, and then you've got life.
Suddenly it jumps off the page and starts running around the room, tearing things up.
Yes, so I've done some more mapping. What I've been doing is I've been mapping on the working groups and the special integration groups of both in COSI, the ISSS, systems dynamics organization, and also operational research. So in COSI has working groups which are let's say focused on understanding the nature of certain system domains. So that's how they map. So they map onto the, where is it? It's the design. They map onto this design power. We've got SIGs. Sorry, we've got working groups which map onto research. We've got working groups that map onto the technical, and we've got working groups that map onto action, intended act. Yeah, so these are developing methods of doing stuff. What I've also done is I've mapped on so there's an international standard for systems engineering lifecycle processes, and these are all of the processes. So this is essentially, these are our processes of doing systems engineering, and what I've done is I've mapped on the processes onto the pathways. So, and again, you can see there's a pretty good coverage. Yeah, so our architecture definition process maps onto generate hypotheses. System requirements definition maps onto exploring potential. Design definition maps onto develop technologies, and implementation maps onto extend what is possible. verification maps onto steering the right time, maintenance maps onto adapt and improve, integration maps onto I put it onto seeking elegance. You know, so you know, I'm not saying the mapping is perfect again, but this is potentially the way that we can justify scientifically our actual engineering processes. And again, you know, how do these things relate to our understanding about systems? You know, this makes it more explicit. You know, how, for instance, decision management could be influenced by our assets, our methods of empowerment and of ability. You get the idea. I'm not saying this is perfect, but it's potentially a starting point how we can relate the science to the actual practice.
Yeah, that reminds me on the personality types and the Myers-Briggs and all. I would say it is science. You know, it's social science.
Yes.
So yeah, and there's a lot of empirical study that supports it.
Yeah. So I'm gonna skip through, but the idea is that once we understand the placement of our SIGs, we could then direct them to do research and knowledge integration related to particular pathways. Yeah. So you know, this cluster of SIGs, for instance, it would be great if they could work on the methods and the research and the you know, the principles which are related to changing your mind, generating hypotheses, losing objectivity, and to address the problem of manipulation of research by funders. You know, so that's what these SIGs could be working towards. Yeah, yeah, as trying to coordinate their activities as components within an overall system, essentially. And we can do the same for in COSI. No,
yeah, I would present it as these are challenges that ISSS could present to the SIGs.
Yes.
Yeah.
Yes. Now the next bit drills down into specific pathways and interactions. So for instance, with no vision of the future situation, there's a forward path which is giving voice to future possibilities, and there's a negative path which is reluctance to change. And I draw on, again, the analogy with chemistry. What we've got going on here is essentially a systemical reaction. The concept of equilibrium, both the forward and the backward pathway are working at the same time. Stuff is happening, but there may be an equilibrium which is achieved and a particular state, and that state can change over time. You can influence the reaction to enhance the forward result or the backward result. Yeah, so potentially we through our system science we could have an influence on these pathways for a more positive result. And that,
I'm surprised you didn't color those blue and red, but good thing you didn't.
Blue and red. Oh yes, we could do. Yes. Now yeah, so this one I think is so we've done this for all of them. So I'll just go through the pathways, just name them. What might be seen, what might be thought, what might be intuited, what might be felt, what might be whole, what might be connected, what might be known, what might be agreed, what might be planned, what might be explained, what might be conceived, what might be explored, what might be envisaged, what might be expanded, what might be governed, what might be intended, what might be done, what might be held, what might be appreciated, what might be improved, what might be learnt, what might be addressed, what might be the way. And here we can see all of the different pathways, you know, as a whole. And if we were to base all of these pathways on our understanding of knowledge about systems, and also be inspired by the way that nature does its system stuff, then we could probably be better at doing all of this with essentially our applied systemics. So these are nature systemics, and these would be our systemics, our applied systemics, based on the science. So in the foreseeable future, the systemist would use their understanding of systemics when they manipulate and transform systems. Now, if we go back to this, this probably would relate to that situation you were talking about earlier, Carl, and some of the things which are working in opposition to this forward path. So the forward path considers how mental models shapes, and this, there will be many more, but this is just the ones that have been collected so far from those 12 works that I mentioned earlier. So considers how mental model shapes our future, imagines scenarios, pays attention and gives voice to the long term, work with activating and resisting forces, and having courage and constructive challenge to authority. So this is the give voice to future possibilities path. And we put a quote here, but what I'd like to do is I'd like to, on each of these pathways, illustrate it with the ideas, the frameworks, and the principles and the assets which are applicable to this particular area. And we could even do cartoons and videos and stuff that would be helpful to help the people understand this situation and what they might be able to do about it. Because there's this negative path, which is the reluctance to change to retain the establishment. So emphasize what would be lost in the new system, reward and make promises to support the establishment, promote fear of the unknown, apply peer pressure to compel people to accept the status quo, discredit the visionary, influence the influencers who have the most to lose, create fear of failing to achieve change, and discredit the timing or approach of the change. So the world hates change. It's the only thing that's brought us progress.
Well, there's some of the events that this could apply to also connects with another organization I'm involved in. It's environmental epidemiology and their ethics committee. And some of what this is showing here is pointing to a lot of the ethical issues that they talk about and that they have to deal with.
Yeah.
So one thing I'm really struck with is that I haven't appreciated before is the power of a framework, one that is complex enough and comprehensive enough and with enough organization in it that you can make sense out of it. All this is within, all that you've shown here today is within a particular framework.
Yeah.
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 And we've managed to do the whole thing without using the word health once.
That's right. Yeah, so back to the drawing board.
Yeah. Well,
that was meant as a joke, of course.
I know, but
this is all health.
Well, actually, yeah. And I mentioned last time we talked, John, that I've kind of come to the conclusion that health is not a thing, but it's a word that points to things. And then the relationships of that to life, what sustains life, what doesn't. And even the diagram that you just had up there a minute ago, Gary, the negative pathways. There are negative pathways. And as you said too, John, even if we can't define health, we can study it. We can talk about it. We can look at the positive pathways and look at the negative pathways.
Well, in fact, the things that we study most intensely are things we don't understand. So if we have too precise a definition of something, it might prevent the study.
One of the things that really struck me on one of the forums that we did on health a couple of years ago was we were talking about, what are things that are healthy, and it went through the usual complexity and fuzziness and everything else. And I said, okay, so what's the opposite of that? What is unhealthy? Boom, boom, boom. There were 5 things immediately listed to it. My question right now, I guess, is this is the full framework and the system and the relationships and so forth. which parts of that, this is the foundation of it, okay? Which parts of that would be most understood and an efficient presentation to a group of engineers on the indoor environment, so that they get the full sense without the full background, because we've only got 90 minutes in a workshop.
Yes, I've got the same problem. I've got to give a 40-minute talk in 2 weeks to a group of systems engineers on systems thinking, and how by applying system science and systems thinking we can change and improve the engineering world. So
well, 12 minutes should be sufficient for that.
Yeah,
but one advantage I like about that is it forces me to really focus in on some of the essential components and make it more clear.
yeah.
And the other part of it, and this is something that we're working on with this conference, is, look, most of us, we know each other. We don't need to really justify. We don't need to have all the, like if you do a presentation on a study, you know, what's the study structure? What's the point of it? You know, you follow all the things, you give the p-values, all that stuff, and then there's a conclusion.
Yeah.
Another way of looking at that is you have a poster, and you walk by these posters and you look at all the data and the numbers and footnotes and everything else, and you have no idea what they're talking about. So another way of generating a poster that I came across a couple of years ago is to put just slightly below the top, the banner. It's like a headline to a story. What's the point of this poster? Then you have the supporting evidence. So what's the point of systems science when it comes to the research of the indoor environment and the practice of the indoor environment?
Yeah.
So that's kind of what I'm looking at.
Yeah.
And I don't mean to discount any of this. Is fascinating and it's important. We have the background for it. We can substantiate it.
Yeah.
Okay.
Yeah.
But what is it that we can actually give them?
I'm gonna have to go, I think, fairly soon, because I'm getting hints that dinner's ready. But what I can do is I can show you very quickly what I'm working on at the moment, and maybe some of what I'm doing might be, I don't know, transportable, or maybe you could use. I'll just show you what I'm working on, and maybe you'll get a sense. So the title of this, Changing the Engineering World with Systems Thinking. Yeah. And what I do is I start off by, so this is going to be the content. So what is the challenge that we as engineers face? Yeah. And then I go into, what is system science, and explaining what it is and relating systems thinking to it, because they know about systems thinking, but I want to go further than that. I want to tell them about applied systemics. Yeah. And then what I then want to do is I want to explain how applied systemics can be applied in engineering, in our technical management, in our conceptualization, and our architecture and design. So that's what I'm working on at the moment. But I start off by explaining what the problem is. So there's this, because they'll resonate with this. And then I go into the impact of complexity and confusion on projects. So project failures and projects not succeeding, and the reasons why, as reported by project managers. And then I go into the problems that we have between systems engineering and project management, and how we talk a different language, and we don't really connect as well as we could do. I talk about the issues that result in us firefighting in our programs, and it's basically an insufficient appreciation of complexity, and the establishment of the enabling system necessary to avoid confusion. That's what's lacking. We don't do enough prior to contract in terms of our exploration of the problem, and our conceptualization, our architecture and design. We leave it until after we've got the contract in some cases, and as a result, we have a huge amount of technical debt, and this leads to major project overrun in terms of cost, time, and budget. often the reason for this is because the proposal phase is managed by sales and marketing, and the project management come in too late, and the systems engineering comes in too late. So we agree a contract for doing something, and it turns out to be massively different because we have, especially on complex projects, because we just don't have a sufficient understanding of the problem. We see this in NASA, and we also see this reported from various engineering projects. You know, the difference in the assumptions that we make prior to contract in terms of requirements understanding and architecture understanding and what it actually turns out to be. And when you multiply all of these factors up, you end up with 500% cost overrun. Yeah, so that's why I'm making it real to the engineers, and then I'll start to go into, you know, this kind of stuff.
Right.
Just giving them a glimpse of it, not going through all of the details we've just been in. But then I want to end up with, you know, leverage points, for instance, from Donella Meadows and how that relates to this kind of stuff. I'm hoping to do something on that. The systems engineering body of knowledge, and, you know, all of this kind of stuff. Yeah, so that's where I'm going with that. I haven't finished with it by any means, but that's the overall idea. And maybe you could do something similar with your people. You know, what is the problem you face? What is system science and systems thinking? And then how can you use that in your particular context?
Yeah, and there's one person in particular I think would be most open to this and interested in it. He's been saying for 5 years now, exhorting them at keynotes, opening and closing keynotes and other times, says, we got all this engineering, well, only looking at indoor environment from an engineering point of view. Where's the sociologists? Where's the medical doctors? Where's the psychologists?
Yeah,
you know? So, okay.
Yeah, we've had a similar problem. So systems engineering is really expanding into that operations domain. Yeah, not just thinking about the technology, but we have to think of the social context, especially when we go into systems of systems engineering and enterprise engineering. You know, we're not just talking about products anymore. We're talking about a whole new enterprise engagement and transformation. So the sociology and the stakeholder interaction becomes absolutely key. You know, we can no longer afford to disassociate our systems from the people. The people are actually in the systems now, and they're vital to the system's performance.
Right. Yeah. Yeah. Okay. Yeah, I'm getting a call for lunch here too. Yeah. So
Okay.
I've recorded the session. I'll send you the link, and maybe
Great.
we could have a follow-up conversation in a week or so, and maybe we could even do some collaboration on any presentation that you're trying to pull together.
That would be good.
Sounds good. I do have 4 comments. Do you want to save them for the next? They are very brief. I could just mention them and then we could leave it for discussion later.
Yeah, they're quick, John.
Okay, so very quickly then, the first one is, as you know, I don't care that much for the Snowden framework. And I looked at it and mapped it out here, and the only real quibble with it is that chaos, I think, is kind of a non-starter. I don't think it really works very well as a causality. And I would suggest thinking about, innovation in that quadrant, because if you think about panarchy, Gunderson Halling and even Tim Allen wrote a book on panarchy. When a system completely falls apart, we would say, oh, it fell into chaos. But that is the point of innovation, where it reorganizes. Anyway, I already mentioned complex versus simple foundation. That's good. I'm going to send you David Kiersey's references. And then the last item was about the comment about health. Everything that Gary presented here has been emphasizing the relational aspect. And so that's the key, I think. And Rosen said that the key to complex systems is to objectify the relation, which is what he's done here.
Okay, right. Time for lunch and a beer. Right. Thanks a lot. I really enjoyed this session. It was
yeah, me too. It's been a long time, Gary. I've been wanting to have a good conversation with you for quite a while. And
thanks, John. It's a real pleasure to meet you, Carl. Thank you.
Pleasure to meet you too, and I look forward to the next one.
Okay.
Thank you.
Okay. All right. Bye.
Okay. Bye.